Hi, and welcome to the second video of this week's lecture. In this video, we are going to look at human technology interfaces in some detail. Now, what I'll do is I'll just move through this slide in a little bit of speed, okay, through the slides in quite quickly, but uh, if at some point you're very interested in looking at a particular thing, stop it, read through the slides, or better yet, look at the readings, which will kind of help you to consolidate what you're learning. All right, so let's move on. So we looked at the hat model and we looked at how the human being can control the assistive technology. And that control happens through the human technology interface, right? And the human technology interface then is defined as the boundary between the human and the assistive technology device across which information is exchanged, right? So if a human wants to use assistive technology, he wants to tell the assistive technology what to do, or the assistive technology needs to know when it needs to assist the human being, right? So there has to be some information transfer, and that information transfer is done by the human technology interface. Hope, okay. So there are various kinds of devices that you can use, right? You can have phones and tablets, which are very, very common. You can have wheelchairs, powered wheelchairs. You can have cognitive assistive technologies, communication devices, various things. And for each of them, the human being has to interact with these technologies. And that is done by the human technology interface. And there are various human technology interfaces in our life. I mean, you can readily think of it, right? So, for example, if you want a light in a room, then you have to go and switch on put on a switch, and so then that switch becomes the human technology interface, right? If you have a mobile phone and you want to send a text to somebody, then you have to press certain icons and do certain things on your mobile phone. And that becomes the human technology interface, and so on and so forth. You can think of many, many different examples like that. So, what are the elements of a human technology interface? So, think about this. If you want to interact with technology, one thing that you need is a control interface, right? Some way in which you can give a control signal to the technology. Then we looked at examples where the selection set was very, very simple. You turn on a light, turn on a switch, the light goes on. So there's a one-to-one correspondence between the control signal and the activity that is performed. But in many cases, you may want a selection set that is more than that, right? So, for example, in a mobile phone, you may want to use the camera of a mobile phone, or you may want to use to text, or you may want to call somebody. Now, so there are like three or four, or maybe 20 different options that you could use the technology for. And those 20 options form the selection set, right? And among this selection set, how are you going to select one of these options? So you may go directly to one of the options and click, and that's what we do in a mobile phone, for example, right? But in some cases, you may not be able to do that. That choice among 20 and just go and choose one may not be possible. So, for example, in a keyboard, if I want to press G, I can just go and press G. But think of a person who does not have hands, so no fingers, let's say. Okay, he can't go and press one alphabet at a time. So maybe you need a more complicated selection method for that person, right? So that's what a human technology interface looks like. So let's look at these in a little bit detail. Let's look at the control interfaces first. So now if you want to control a technology interface, you can use control signals from various parts of the human body, right? You can, especially from the parts of the human body that you can actually voluntarily move. So you could use the head, the eye, the arms, the hands, the knees, the legs. You can have these movements control, let's say, a switch or something like that, and that gives the control signals um, to the technology interface. But also you could have, for example, a nod of your head which controls the interface. You could have blinking of eyes. You can have breathing. So you breathe, you can blow something. So if you puff, that could turn on a control, that could be the control signal. Or there are various kinds of ways in which you can pick up control signals from the human body. Right, and in this table there are some characteristics of these, right? So for example, let's just take two examples. So with fingers, the resolution of your of the activity that you can do is very high, right? You can move your fingers actually very across very small distances, and that could give you different control signals. But if you have the entire hand and you had to move it, the resolution reduces, it's just moderate. With your arm it will be still lower, and so on and so forth. So there are various characteristics here which I'm not going to go through every one, but for each of the control interfaces you can have different resolutions, different ranges, different strengths, different versatilities. Okay. Uh, Now, one of the control interfaces are limited by what the person can actually use, right? Let's say a person has a spinal cord injury at the level at C3 level. Then the only motion that is available is neck and up, right? He can move the neck, maybe he can control his cheek, but other than that, he can't do anything else. And therefore, you cannot use hands as a control signal in that case. But let's say if the spinal cord injury is at the T2 level or T2 to T12 level, then you have control of the upper um, body. So you have control of the hands, but very low control of your legs, and that means that you can't have control interfaces on your leg. I mean, these are fairly straightforward things, right? But you can look at details here if you want to. Uh, Also, the question would be, okay, now we have the control sites. What would be the way in which the control interface is switched on? So you could have mechanical switches, right? Switches that you actually press. So, and switches can be turned on with legs, with arms, maybe with your head and things of that kind. Or you could have electromagnetic switches, right? Where you are using electromagnetic energy to switch on or turn on the light. Or you could have electrical switches, which means that you're looking at the signals from the body, electrical signals. So, for example, EMG from a muscle, or maybe EOG from your eyes, electro optical, oculogram, right? O stands for ocular, not optical. Oculogram. Okay, so those are basically muscle signals that are recorded from the muscles in your eyes, and that could kind of trigger a switch. You could also talk about proximity switches. So if you go close to a thing, it turns on. You could have a pneumatic switch, which uses breathing as a switch. So if you puff, maybe a switch gets on, or things of that kind. Or you could have a sound switch, right? You could have make a sound, and that turns on a switch. So there are various ways of activation. Uh, so what we have seen is you have different control sites that you can use, and at each control site you can have different kinds of activation methods or user actions that can be done to actually record the control signal. Also, another question could be, okay, now that we have a switch, now think about this. So let's say we have a person who's paraplegic and he can't really use his hands and legs, and the only thing that he can do is maybe a movement of one finger. Okay, so we identify that as the control site, and we put a switch there. Now that switch, how are you going to use that switch? Because if you want that switch to do only one function, then you can just have a on and a off, and that's it. But it may be more tricky than that. Maybe you want many more functions to be done, and you could use that to, for example, you could have a time dependent switch, right? So how long do you press the switch depends on what activity you get to do. Or you could say, well, you could press the switch like for a very short duration of time, tap it to move across the selection set. And when you want to select a particular thing, you have a long click. That's something like how we use our mouse, right? You well, a mouse is slightly more complicated, but still you have the single click and the double click, and they can be used in different ways in your in the computer. And similarly, you can use the switch also in different ways. Okay. What happens many times is that some control sites are not trained enough to be used as a control interface. So, for example, let's say you are a person who is not able to really use your head to and nod it in particular ways or do something so that you can actually detect a control signal from there for assistive technology. One of the things that you can do is you can train yourself. You can train the person with the disability so that he can produce reliable control signals. And there are various ways of training, right? So here, this girl is having a paintbrush on her head and she's trying to paint. And while she paints, she learns how to control her head in and control the fine movements of her head, right? This young girl here is just playing with some toys, and that is giving her some kind of training as to how to use her hands to get control signals. Okay, so we've looked at the control interface aspect of the human technology interface. Let's look at the selection set. Okay, we're looking at the selection methods first. So one of the methods that you can have is direct selection. What we mean by direct selection is that you have many options in your menu, and all the options are put in front of you in one time, and you just directly go and choose one of the options. Okay, this is how a keyboard works, or this is how a mobile phone works, where all the icons are there on the mobile phone, and you just say, okay, oh well, I want Facebook, so I just go and click on that, and that's it. Okay, so that is called direct selection. Now, and there are various examples here, right? So you can have keyboards that have more distance between the characters in case you can't have very fine resolution, like in normal keyboards. You can have keyboards which have bigger letters. You can have keyboards like this, which are much more widely spaced and things of that kind. But it is possible that people don't have enough manipulation capability to actually do this kind of direct selection. So, for example, let's say there is a person whose fingers don't work for whatever reason. For some reason, they can't actually move their fingers and make a choice. Okay, their hands can move, but their fingers don't move. One of the examples would be if they have Parkinson's. Okay, their hands tremble quite a lot, and because of this trembling, they can't really make a choice. Okay, so one very simple assistive technology in that case would be to, for example, give them a pointer. So give them a pointer like this, okay, which is much more sharper, and then they can make a choice much more accurately, right? That could be an example. Another example could be, let's say you want to use a keyboard or a tablet when your hands and when you can't really use your hands and legs, but you want to use your mouth. Now, mouth does not have that good. I mean, how are you going to touch a particular icon with your mouth? So maybe one of the things is you could give them a mouth device or something like this, which you put in your mouth, and then you can use your mouth to go and touch a particular icon, right? So there are various ways in which you can do this. And some of those things are pointed here. Um, so, for example, you can have a finger splint, you can have a typing stick, and other stuff which I'm not going to go into. You can take a deeper dive into those kinds of technologies if you are interested in them. Here are a few examples of what I was talking about. So you can see this wrist splint which you can use to access the keyboard. Here's this girl wearing a headband with a pointer here which she can use to, for example, touch the keyboard and type using head movements. You could also have keyboards with protective casings like this, so that when you have tremors in your hand, you don't accidentally press the next icon, because you are going in for these big holes, and the holes actually guide your finger to touch only one of the icons. And similarly, you can have protected keyboards with casings which uh, um, uh, prevent, what should I say, confusion. When you want to touch A, you don't touch S or the caps lock and things of that kind. So that was direct selection. But in many cases, direct selection may not be possible, right? And direct selection involves much, quite a bit of fine control of fine control, manipulation control. You should be able to move directly between various points in space. But there are many cases when that is not possible. I mean, one example is what we looked at before, where a person is paraplegic and he has only one finger moving. Uh, you can't really ask them to directly select various things on a screen because their hands don't move. So what do? You could have what is called indirect selection. One example of indirect selection would be scanning, right? So let's say there are three things in the menu. You can either turn on the TV, you can turn on the lights, or you can turn on the radio. It's a very simple example, okay? But you really can't choose between TV, lights, and radio because you don't have the motor capability to do these three switches. So instead, what could happen is you can have only one switch in your hand and you're looking, and first the TV light goes on, let's say. And if you press the switch, the TV will be on. But if you don't, after some time, the lights switch goes on. After some time, the radio goes on. Wherever you press, if you press when we are in this state, the TV gets on. When you press in this state, the lights go on. When you press in this state, the radio goes on. So can you see how using one switch you can have you can select in your selection set. You can make an indirect selection. This is called scanning. And there are various ways of scanning. Here, for example, this girl is selecting by looking at the various colors that she wants to use. You could also have a similar kind of a scanning for more options, right? You can, for example, scan the rows, select a particular row, and then you can scan the columns so that you get to the particular item that you want to get. Does that make sense? Uh, Another way could be you press to advance the row, you press to advance, well, probably not. That would, I mean, you can have two different kinds of presses and all, but we'll come to that in a moment. Okay, so there are various kinds of selection techniques here, right? You have wait, you have activate, hold, release. As I was saying, that you don't, it just doesn't have to be wait and press, but it could be press, long press, double press, and so on and so forth. But all of them have different problems associated with it, right? Because some things may be more difficult to do for certain people than others, and we have to just think about what we are doing at that point. Okay, and there are a variety of switch control interfaces here. We have looked at these already before, and therefore I'm not really going to go into details here. And these are some pictures, right? You can have switches like this. You can have these are also switches of other kinds. You can have joysticks, and you can have big controls for the joysticks so that you can use the entire arm or the entire head to move through a particular selection option. Okay, what other methods can you use? I mean, we just talked about joysticks. Joysticks, you know what a joystick is, right? And you can use the joystick to kind of have directed scanning and then select a particular item. So, for example, if you want to select this item, you can, using the joystick, you can move down and then this way and then this way, and you can reach this place. So basically, then what you can do is you can have limited motor capability, but you can do much faster scanning. However, the problem is still you need some kind of motor capability, right? Your range may be very small, but you still need to have fine motor capability to be able to direct a joystick correctly. You could also have coded access, right? You could use Morse code or some kind of output, and you can put a table like this, a Morse code table in front of a person, and they can just use one switch to kind of tell you something, and that is a possibility. Uh, you could also have display based coded access where you select, for example, uh, the first letter is, let's say, P, and then you want to select a T, then you put a, if you press a long, if you do a long press, that's a dash, you select T. If you do a dot, then you go to E, and so on and so forth, and you can reach using uh, different, what should I say, combinations of dashes and dots. You can reach different letters or different icons in your selection set. Okay. Now, the thing with all this is that there are different kinds of capabilities that are used, right? So, for example, if you could memorize the Morse code and use it, you don't need vision, and so visually impaired people, people with visual impairment, can also use these. But if you have a chart, then people can actually see it, um, and which means that I can. It's not just that the person can see it, but also the other person who is trying to decipher what this person is trying to say can also see it, and they both can communicate. So there are different kinds of cognitive abilities that are required for each one of them, and we'll have to kind of, what should I say, uh, we'll have to work with the person, and therefore the human aspect becomes very important, isn't it, as you do the assistive technology to see what they can use. You could also now, one of the limitations of all these indirect selection methods is you can see that accessing a particular menu option or a particular option in the selection set is not that easy in this case, right? It takes time because you have to just wait for all the scanning to happen before you make your selection. How can you increase the rate? Right, so rate enhancement basically refers to the fact that you generate a greater number of uh, characters than the selections that the individual actually makes, right? And there are various ways of doing it. One of the ways of doing it would be to use, for example, in texting, for example, you have predictive word options. So you just press T, and already THE comes. And if you just press one more button, that goes into your text. Or you press AP and you get the option Apple, and you can just select it. So instead of typing 6 letters, you only have to type 2 or 3, and you can select the words, and therefore you have a rate enhancement, right? And so there are various ways of enhancing rate in indirect selection options. Let's look at human technology interface output. Now, technology interface is not just for inputting to the technology, but the technology also needs to output. And you can have many, many different kinds of outputs, right? You can have, for example, speech as a HDI output. But let's say if you and especially if there is a person who's visually impaired, screen readers or print material reading machines, or having print material available in alternate reading formats, all those can be the outputs of the human technology interface. uh, Speech itself can be digital recording, or it can be synthesized speech, and both have their own advantages and disadvantages. Now, now that we've looked at the human technology interface, we've looked at the control, we've looked at the selection set, we've looked at the selection methods, right? Now, how do we know which of these methods is useful for the person that we are trying to fit assistive technology to? And that's where assessment comes in. And now, many of these things would be quite, would kind of feel very simple to you, but let's just go through that, right? You would want to first of all look at what is the activity that the person wants to perform, right? The needs identification. And secondly, you will have to do a physical sensory evaluation. What kind of sensations does the person have? Can he hear? Can he see? Right? What kind of motor control does he have? Which control sites can actually be used? And based on both these, you can then talk about some control enhancers and go either for direct selection or indirect selection, or some modification of both of these, which would be appropriate to the user. Hopefully, that gives you a sense of how we would design human technology interfaces.